Next is question number 49. A very good question from inverse trigonometric functions. So let us solve it. Here a function fx is given to be equal to sine inverse root 3 by 2x minus half into under root of 1 minus x square. So let us here put x equal to sine theta, where theta belongs from minus pi by 2 to pi by 2. So we will get fx equal to sine inverse of root 3 by 2 can be written equal to cos 30, right? This is cos pi by 6 and x is sine theta. So it can be written as sine inverse of sine of theta minus pi by 6, right? Now here we know that theta is going from minus pi by 2 to pi by 2. So theta minus pi by 6 will go from minus 2 pi by 3 up to pi by 3. So it will be equal to minus of theta minus pi by 6 minus pi, when theta minus pi by 6 belongs from minus 2 pi by 3 to minus pi by 2, and it will be equal to theta minus pi by 6 when theta minus pi by 6 belongs from minus pi by 2 to pi by 3. Now putting back the value of theta, this will be equal to minus theta, that is minus sine inverse x, minus pi plus pi by 6, that is minus 5 pi by 6. Similarly here putting the value, we will get x belonging from minus 1 to minus root 3 by 2, and it will be equal to sine inverse x minus pi by 6 when x goes from minus root 3 by 2 up till 1. So this is our function fx. Now let us solve option by option. Option number A, we have to find the integral from minus 1 to 1. So integral from minus 1 to minus root 3 by 2, we have minus sine inverse x minus 5 pi by 6 into dx plus minus root 3 by 2 up till 1, we have sine inverse x minus pi by 6 into dx. Now this will be equal to, we know the integral of sine inverse x by parts, that is equal to x into sine inverse x plus under root 1 minus x square. So putting it here, we will get it equal to minus x into sine inverse x minus under root 1 minus x square from minus 1 to minus root 3 by 2. Also minus pi by 6 into x from minus 1 to minus root 3 by 2 plus integral sine inverse x, that is directly putting the value, putting 1, it will be 1 into sine inverse 1, that is pi by 2 plus 0 minus putting x equal to minus root 3 by 2, we will get minus root 3 by 2 into sine inverse of, let's put minus out, so it will be root 3 by 2 plus under root of 1 minus 3 by 4, that is under root of 1 by 4 minus pi by 6 into 1 plus root 3 by 2. So solving it, we will get it equal to minus 1. So option number A is correct. Similarly solving option number B. Now from minus root 3 by 2 to root 3 by 2, that is we just have to solve the integral sine inverse x minus pi by 6 into dx, and the limit is from minus root 3 by 2 up till root 3 by 2. Now we know that sine inverse x is an odd function, so its integral from minus root 3 by 2 up till root 3 by 2 will be 0, right? So we are left with minus pi by 6 into 2 times root 3 by 2, that is root 3, that is equal to minus of root 3 into pi upon 6. That is given in option B, so this is also correct. Now, we have to find whether fx is increasing or decreasing function. Now, for x going from -1 to minus root 3 by 2, we have, that is, for x going from -1 to minus root 3 by 2, its differentiation will be equal to f dash x will be equal to minus of 1 upon under root 1 minus x square. Also, for this interval, it can be seen that its differentiation is 1 upon under root 1 minus x square, which means that it is increasing for the second interval, but it is decreasing for the first interval. So, in the given options, it has been given that it is increasing from 0 to 1, which is true. And in option number D, it has been given that it is decreasing in -1 to 0. That is not true, because it is decreasing only from -1 to minus root 3 by 2. So option number D is incorrect. So answer is A, B and C. Next, let us discuss question number 50, which says that consider three functions f1x equal to x square, f2x equal to root x, f3x equal to sine pi by 2x, defined in the interval 0 to 1. If a1, a2, a3 denote the areas bounded by the pairs, a1 is the area bounded by these ones, and a2 is the area bounded by these ones, and a3 is the area bounded by these ones. So we have to find their respective values. Now, firstly, let's make the graph of the three functions. f2x will be something like this, because we know the graph of y square equal to x, that is y equal to root x, and the graph of y equal to x square, that is something like this. And we have to find the graph of sine of pi by 2x. That is the most interesting one. Now here we know that its slope is 0 and its slope is infinite here. Now the slope of sine of pi by 2x, that is pi by 2. So its graph will be something like this, because at x equal to 1, it will be horizontal, right? So it will cut the graph y equal to root x at x equal to 1 by 2, right? Now let us firstly find the value of a1, that is equal to the graph of y equal to f1x. This is f1x, and this is f2x, and this one is f3x. So a1 will be equal to the simple one, that is integration of root x minus x square into dx from 0 to 1. So this will be equal to x raised to the power 3 by 2 upon 3 by 2 minus x cube upon 3, and the limit is from 0 to 1. So that is equal to 2 by 3 minus 1 by 3, that is 1 by 3. Now value of a2, that will be equal to, which means that option number A is correct. Now let's find a2, that is between f3x and f2x, that is this one and this one. Okay, so this is what we have to find the area. Now area will be equal to, from 0 to half, it will be root x minus sine pi by 2x into dx, plus from 1 by 2 to 1, it will be sine pi by 2x minus root x into dx. This is what we have to find. So this will be equal to x raised to the power 1 by 2. Its integral will be 2 by 3 into x raised to the power 3 by 2. That is, putting the limit as 1 by 2, it will be 1 by 2 raised to the power 3 by 2 minus integral of sine pi by 2x, that will be plus of 2 by pi into cos pi by 2x from 0 to half, plus, now its integral will be minus 2 by pi cos pi by 2x from half to 1, minus its integral will be x raised to the power 3 by 2 upon 3 by 2, and limit is from half to 1. So this is equal to 2 by 3 into 1 by 2 raised to the power 3 by 2, plus putting x equal to half, we will get 1 by root 2, that is root 2 by pi minus, putting x equal to 0, we will get minus 2 by pi, plus, here putting x equal to 1, cos pi by 2, that is 0, minus, we will get 2 by pi into 1 by root 2, that is root 2 by pi, minus, here putting x equal to 1, we will get minus 2 by 3, plus 2 by 3 into 1 by 2 raised to the power 3 by 2. So these two have got doubled and these two have also get doubled. So this will be equal to root 2 minus 1 into 2 by pi minus root 2 by 3. That is given in option number C. So this is correct. Also we have to find A3, that is the area between F3x and F1x. So A3 is equal to integral from 0 to 1 sine pi by 2x minus x square dx. So this will be equal to minus of 2 by pi cos pi by 2x from 0 to 1 minus x cube upon 3 from 0 to 1. So this is equal to minus 2 by pi into cos pi by 2, that is 0, minus 2 by pi into cos 0, that is 1, minus 1 upon 3. So this is 2 by pi minus 1 by 3. That is given in option number D. So this is also correct. So answer of this question is A, C, D. Next is question number 51, which says that a curve fx equal to integral sine cube x into secant x upon 1 minus 2 sine square x passes through the point 0, this one, and fx is given to be equal to a into ln of modulus of gx such that g of pi by 6 is 9 by 2. Then we have to find the range of fx and we have to find the value of a. Now, here firstly, let's take up the term sine cube x into secant x upon 1 minus 2 into sine square x. So let us firstly solve it. It can be written equal to tan cube x upon secant square x minus 2 times tan square x. So that is equal to tan cube x upon secant square x can be written as 1 plus tan square x, that is 1 minus tan square x, right? Now this can be written equal to tan x into tan square x. Now we know that secant square x is 1 plus tan square x. So it can be written as secant square x minus 1 upon 1 minus tan square x. So it can be written as tan x into secant square x divided by 1 minus tan square x minus tan x upon 1 minus tan square x. So we have to find the integral of these two terms. So this is equal to, taking 1 minus tan square x equal to t, we will get minus 2 times tan x into secant square x into dx equal to dt. So let us multiply and divide it by minus 2. So it will be equal to integral of dt upon t minus, here multiplying and dividing by 2, we will get it equal to integral of tan 2x into dx. So this is equal to minus 1 by 2 into ln t, that is ln of mod of 1 minus tan square x minus, now its integral will be minus 1 by 4 into ln mod of secant 2x plus constant. Now here it has been given that it is passing through this point. So if I put x equal to 0, then value of y will be equal to minus 1 by 4 ln 1 by 4. So this is equal to ln 1, that is 0, and here also we will have secant 0, that is again ln 1, that is 0. So this is the value of c. So we can say that fx is equal to minus 1 by 4 into ln of 1 minus tan square x whole square into secant 2x, that can be written as in the denominator cos 2x plus constant, where constant is minus 1 by 4 into ln 1 by 4. So this is equal to minus 1 by 4 into ln of, now we know the formula of cos 2x, that is cos 2x is equal to 1 minus tan square x upon 1 plus tan square x. So 1 minus tan square x can be written as cos 2x whole square. That in the denominator will cancel with 1 cos 2x. So it is cos 2x into 1 plus tan square x whole square. That is secant square x whole square. That is secant x raised to the power 4, and minus 1 by 4 ln 1 by 4 can be taken inside. So we will get in the denominator 4. So this is equal to minus 1 by 4 into ln of cos 2x upon 4 times. Now cos 2x is equal to 2 into cos square x minus 1. So we can here write cos x raised to the power 4 as cos 2x plus 1 upon 2 whole square. So these 4 will get cancelled. So this is equal to minus 1 by 4 into ln of cos 2x upon cos 2x plus 1 whole square. So this is equal to 1 by 4 into ln of cos 2x plus 1 whole square upon cos 2x. So it can be written equal to 1 by 4 into ln of cos 2x plus secant 2x plus 2. So this is the final solution that we get. Now here we can see that gx is equal to cos 2x plus secant 2x plus 2. So let us verify it. If I put x equal to pi by 6, then it should be equal to 9 by 2. So this is equal to cos of pi by 3, that is 1 by 2 plus 2 plus 2, that is 4 plus 1 by 2, that is equal to 9 by 2. So the function gx equal to this is correct. Hence we can say that the value of a is 1 by 4. So option number A is correct. Also the range of fx's are. So option number C is also correct. Next is question number 52, which says that consider a function fx equal to this one. A determinant is given. So we have to find the values of x which satisfy fx equal to 0. Now fx can be written equal to, if we apply the operations column 1 as column 1 minus column 2 and column 2 as column 2 minus column 3. So what will we get? Tan x minus sin square x, cot x minus cos square x, and here we will get 0. Similarly, sin square x minus cot cube x, cos square x minus tan cube x, 0, cot cube x, tan cube x, and 1. So we have to put fx equal to 0. Now solving this about this element, so we will get tan x minus sin square x multiplied with cos square x minus tan cube x minus sin square x minus cot cube x multiplied with cot x minus cos square x is equal to 0. Now, so taking sin x by cos x common, we will get 1 minus sin x into cos x multiplied with cos square x minus tan cube x minus, similarly here taking cos x upon sin x common, we will get from here, so we will get 1 minus sin x cos x multiplied with sin square x minus cot cube x is equal to 0. Now here it can be seen that these two are common in both. So either 1 minus sin x cos x is equal to 0, taking common, or multiplying this inside, we will get sin x into cos x minus sin 4x upon cos 4x minus sin x into cos x plus cos 4x upon sin 4x is equal to 0. So here it can be seen that these two will get cancelled. So Taking LCM, we can say that cos 8x minus sin 8x is equal to 0, which means that tan x raised to the power 8 is equal to 1. That is, tan x should be equal to plus minus 1. So these are the two solutions that we get, either this one or this one. Now, if we multiply both sides by 2, we will get 2 minus sin 2x equal to 0. That is, 2 is equal to sin 2x. Now, this is not possible, so we don't get any solution from here. Now, tan x equal to plus minus 1 will give us x equal to n pi plus minus pi by 4 for n belonging to integer. So, from the given options, it can be seen that the correct answer is option number C and D. So, C and D are the correct answer. Next is question number 53, which says that a beam of rays incoming along the plane PI strikes a plane mirror PN. If all the reflected rays lie on the plane PR and we have been given the angle between plane mirror and the plane containing reflected rays, then which of the following options is correct? Let us say this is the plane mirror, these are the incident rays and these are the refracted rays, right? This is the incident rays, that is, this is PI, and this is the refracted plane, that is PR. So the normal plane can either be this one or this one, right? The normal plane can either be this one or this one, which means that normal plane is the angle bisector of PI and PR. So let us find PN. That will be equal to 3x minus 4z upon 5 equal to plus minus 4x plus 3y upon 5. So the two planes that are possible are 7x plus 3y minus 4z equal to 0 or x plus 3y plus 4z equal to 0. Now, it has been given that the plane mirror, this one, have the coefficients of x, y, z, that is a, b, c, as positive integers. So, the plane is definitely not this one and the plane is this one. So, we can say that the value of a is 1, b is 3 and c is 4. Now, from the given options, option number A, it is said that a plus b is equal to c, that is correct. Also, ACB, that is 1, 4, 3, are they in AP? No, so this one is incorrect. Also, we have to talk about P, Q. Now, it have been given that angle between the plane mirror and the plane containing reflected rays. Now, we have to find the angle between this plane mirror and the reflected plane, that is this one. So, cos theta will be equal to 4 plus 9 upon under root of 1 plus 9 plus 16, that is root 26 into 5. So that is equal to 13 upon 5 into root 26, which means that value of P is equal to 13 and value of Q is equal to 5. Now, it have been said that P, Q are prime numbers, that is true. Also, option number D says that 3B, that is 9 plus 4, that is 13 upon 5 is equal to P by Q, that is also true. So option number D is also correct. So the answer of this question is A, C and D option. Next, let's discuss question number 54, which says that if ABCD is a parallelogram, point A1 divides AB in this ratio, A2 divides BC, A3 divides CD and A4 divides DA. If triangle ABC denotes area of polygon ABCD, then we have to find the area of all these. Right. Let us say this is the parallelogram A, B, C and D. Let us say the points are 0, B vector, C vector and let us say it is C minus B vector. Now A1 divides AB in the ratio 1:1, that is it is the midpoint, that is B vector upon 2, and A2 divides BC in the ratio 1:2, that is the point is C plus 2B upon 3. Similarly, A3 divides CD in the ratio 1:3, so the point will be 4c minus b upon 4. Also, point A4 will be 4c minus 4b upon 5. So these are the 4 points. Now we have to find area of A1, A2, A4. So let us firstly find the vectors, that is A1, A2, that will be equal to A2 vector minus A1 vector. So we can write it directly as B plus 2C upon 6. Similarly, let's find the vector A1, A4 vector, that is equal to A4 minus A1 vector. So that will be equal to 8C minus 13B upon 10. Next, let us find vector A3, A2 vector, that is A2 minus A3, 11B minus 8C upon 12. Similarly, let's find A3, A4 vector, that is A4 minus A3, that is minus 4C minus 11B upon 20. Now, we have to find the area of triangle A1, A2, A4. That will be equal to half times modulus of A1, A2 vector cross A1, A4 vector. So, this will be equal to half into this and this one. That is, in the denominator we have 60. 8 times B cross C minus 26 times C cross B. That is 8 plus 26 times B cross C. That is 34 times B cross C. Similarly, let's find the area of triangle A2, A3, A4. That will be equal to half times modulus of A3, A2 vector cross A3, A4 vector. So that will be equal to half into this and this one. So minus 44 times B cross C and plus 88 times C cross B. That is B cross C into, that is minus 44 minus 88, that is minus 132. So we will get 33 upon 60. Now area of quadrilateral A1, A2, A3, A4 will be equal to sum of the above two, that will be equal to 34 plus 33, that is 67 upon 120 into B cross C vector. Now we have to find area of ABCD also. Now area of ABCD, that will be equal to AB vector cross AD vector. So that will be equal to B cross C vector. Now we have to find in option number A 67 upon 120 upon 1. So this is correct. Option number B, we have to find A1, A2, A4 minus A2, A3, A4. That will be 1 upon 120 upon 1. So this is also correct. Now we have to check which one is larger. A1, A2, A4 is greater than A2, A3, A4. So option number C is also correct. So correct answer of this question will be A, B and C option. Next is question number 55, which says that if the roots of the equation z raised to the power n equal to 1 are the vertices of a n-sided polygon on the argand plane whose circumradius and inradius are r and r respectively, such that the range is given of r upon r, then we have to find the value of n. So let us say the roots of z raised to the power n are lying on this circle. Let us say this is z0 and this is z1 and so on. So this whole is 2 pi by n. If we join these 2 points and draw perpendicular from origin on this one, then let us say this angle will be pi by n and this is capital R and this is small r. So we can say that cos of pi by n will be equal to r upon capital R. Now it have been given that cos pi by n is going from 1 by 2 up till root 3 plus 1 upon 2 root 2. That is pi by n is going from pi by 12 up till pi by 3. That is n belongs from 3 to 12. So From the given options, it can be seen that all the values are given in between this interval, so it can take any of the 4 values. So the answer of this question will be A, B, C, D. Next is question number 56, which says that let lambda n, Sn and Sn, small sn are given and they are related by this one where P and Q are co-prime to each other. Then, now here it have been given that lambda n is equal to summation r equal to 0 to n r cube upon NCR. So here if we put n minus r equal to t, then it will be equal to summation, when r is 0 then t will be n, that is t will go from n to 0, that is same as t going from 0 to n. So that will be equal to n minus t whole cube upon nc. Here I can write n minus r, that is t. So that is equal to summation t is equal to 0 to n. Expanding it, we will get n cube minus t cube minus 3n square t plus 3n t square whole divided by nct. So this can be written equal to summation of n cube upon nct, that is equal to n cube into summation of 1 upon nct, that is same as small sn, right, minus summation of t cube upon nct, that is same as lambda n, minus 3n square. So we have to find this out, summation of t going from 0 to n, t upon nct, plus taking 3n common, summation of t square upon nct, that is same as capital Sn. So we just have to find this value. Let us say it is equal to an. So that is equal to summation t equal to 0 to n t upon nct. Now if we put n minus t equal to k, so that is equal to summation k equal to 0 to n minus k upon nck. So that is equal to n can be taken common, summation of 1 upon nck, that is same as small sn, minus k upon nck, that is again equal to an. So 2 times an is equal to n into Sn. So we get the value of an from here. Let us put it back down here. Now taking this lambda n on the left hand side, this can be written as 2 times lambda n equal to n cube small sn minus 3n square into an, that is n into small sn upon 2 plus 3n into capital Sn. So lambda n is equal to 1 by 2 times minus n cube upon 2 into small sn plus 3n into capital Sn. Now from the given statement we can compare with capital Sn. It has been written 3 by 2n, that is 3 by 2 is equal to p by q. Also with small sn we have minus n cube upon 4, that is equal to minus n raised to the power p upon 2q, that is the value of p is equal to 3 and the value of q is equal to 2. So from the given options, which of the following are prime numbers? P is a prime number, Q is also a prime number, P plus Q is also a prime number, P minus Q is not a prime number. So the answer of this question will be A, B, C.